Hello YouTube, this is Chesko from STEM APKs. Welcome to another tutorial. In this tutorial we're going to continue with chapter 2 of Gary Bradsky's book, and we're going to be talking about pyramids. And this is the code that it is in chapter is example 2.5. What I did was I wanted to show you what it looks like, because I'm going to be tweaking that one a little bit. He shows you how to do the pyramid downsampling. I'm going to show you how to use the upsampling. That way you know how to go up and you also know how to go down. Okay, but before we do that, the first thing we have to do is to SSH into our Raspberry Pi. So we're going to do that now. And now we're in, and like always I open a second terminal. Okay, so now we're in, then clear this, and then okay. The first thing we're going to do is go into the directory that we did last time, and I'm going to be copying a couple files from here. I'm going to do this, but before I do that, let me run this code so you know what it does. I'm going to run this code right here, and I'll show you what it does. And what is this called? It's called reduce size. Reduce size is this one right here. Okay. And as you can see, it takes the image, the famous Lena image here, and it does downsampling by 50%, and he explains it here. As you can see, it takes the reduction of an image by a factor of 2, and it's accomplished by using this pyramid down function, which performs a Gaussian smooth and then removes every other line from an image. Okay, like I said, I'm not going to be going down. I'm going to be going up, and let's do that. And the way we're going to do that is, first of all, I need to copy a few files. That one, cmake list, and I'm gonna copy this one and that one and that one. Okay, so you know what I'm doing. So pyr down pi pyrUp cpp and reduce size pi, and I need Lena JPEG, and it's gonna go to a folder that I have not even created yet. We're going to create it right now. It's gonna be called Tutorial-9. Let's do that here. Make a directory, Tutorial-9. File exists already. Whoa, how come it exists? ls, yes, it does exist. So remove rf Tutorial-9, and it's now gone. Clear. Let's try again, and it's not a directory because I have not created. Make a new Tutorial-9, and now I can do, and it's, if we check now, cd, can't type today, my goodness, and there it is. Okay, so let's clear. Oh my goodness, is it me or is it keyboard today? What I'm going to do first of all is show you the code and how I tweaked it. As you, that's why I have this one here side by side so you can see. I took this one out, this assert, I commented it out as you can see here, because we're not dividing by 2, but I'm gonna be, you see here he has modulus 2, making sure that it's even. We don't need it because I'm multiplying, okay? And also here he's dividing by 2, here I'm multiplying by 2. And the channels, the depth is the same, and here of course the function, instead of going pyrDown, I'm going pyrUp. Okay, and we can close this here. So now what we're going to do is clear this and cd cv Tutorial-9 ls, and then cmake. Let's start compiling. And there's an error. ls clear. First of all, nanos. I think I forgot to change the name. Yep, I didn't change the name of the cmake. So what is it going to be called? It's going to be called pyrUp. And it's going to be called pyrUp. And it's going to be called pyrUp. I think that's what I call it. Yeah, it's CPP. Okay, and then the libraries also pyrUp, and now it should work. Let's try again, and it's done. Now let's link and build. And it should be doing if I show you this one, it goes by it divides by 2 by a factor of 2, and you're gonna see that this one, instead of going down, is gonna go up by a factor of 2. And as you can see, the executable, it was created, so let's run it. And as you can see, whoa, it's a big one. It really went up. Okay, instead of this one, it became that huge picture, as you can see. Okay, and this way you can, now you know not only how to go up, you also can go down. And it's a very nice function that you use it all the time. You'll find that you will use it all the time. Okay, but now that's in the Python and C++ world, but now I'm going to be showing you the Python world, and I think I have it here. So let's clear, and I'm gonna, if you have any questions on the Python side, there's this I just restarted the computer, so actually pyrUp Python, you can go to this page right here, and they do a pretty good job explaining the pyramids and in Python's and pyrUp and pyrDown, and how the Gaussian pyramids, Laplacian. This is what we did 2 tutorials ago. That was the blending. Okay, but it's a very good page. They do a pretty good job explaining the Python side of the OpenCV libraries. So let's continue. This is the code. What is it called? ls nano pyrDown pi. And this is the code. As you can see, it's importing these computer vision libraries. This is straight Python, nothing new there. I'm making sure that here that there is an image. If not, it will throw an exception. Here is reading and decoding the image, making a cloning it, a copy. Is a for loop that is gonna, this is where is the pyramid down is going down, and then it's gonna display the image, it's gonna resize the image, and you're gonna see what it looks like. Okay, so that's the Python side. I'm going to be including this in my website, so don't worry about it if you didn't have enough time to copy it. Python PyRdown Py, and as you can see, it's gonna blur it like he says here in the book. You can see it performs a Gaussian smooth. This is what's going on right here. The smoothing is going on there. This is the PyRdown, the result, and this is here is the original image. Okay, as you can see, this is with the Python side of the affairs. So, but I wanted to show you something a little bit different. That also, this is using the pyramid, but if sometimes if you want to use scaling, sometimes you don't want to use pyramid down, you want to use something simpler. I did this one here also that I tweaked some of this code that they have here. I took some of it and just tweaked it in a way that you're gonna see, and it's using the scaling, the resize function, and I called that one nano reduce. But sometimes you use this type when you're doing something that you don't need to be. Let me show you here. It's just importing cv in NumPy, is reading, decoding it, height and the width, and it uses something similar, but this is where it is. I wrote it in a way that you can either go divide by 2 to go down. Instead of using the PyRdown, all you're doing is using this function right here. So instead of using cv.pyrDown, you're using the cv to resize, and you use dividing by 2 to get the same factor of 2 that he's talking about here. And you're using the intercubic. You have many choices. If you go here to that page that I showed you earlier, you don't have to use intercubic. There are many choices that you can use. Take a look at that page, and it will open a window named result and open a window doing input. Okay, and everything else is the same. I'm gonna be showing you how that one works. Python reduce size, and as you can see, it takes the original and it reduces it to 50% of what it was, just like the other one did. But if you do this one now, and instead of doing the resizing PyRdown, let me show you. You comment that one out, and you, instead of dividing by 2, you're multiplying by 2. Okay, so let's run that one again, and you'll see the result that is going to be similar to the one that we had before, and you can see the big one here. Okay, instead of going down, it went up, and this is doing it using Python. Okay, so now you know how to do it with C++ going up, going down, and with Python going up and going down, and also if you just want to do scaling without having to use the pyrDown or pyrUp. Okay, this is the end of the tutorial. If you like this tutorial, please click the like box and subscribe to my channel, and I will see you next time. Thanks for watching.